Hi, welcome back to Data Management with Stata. I'm Ben Littenberg. This is module number 6, Dates and Times, because Tempus fugit. The agenda for module 6 is 2 sections of the Mitchell textbook, chapter 5.8 and 5.9. And we're going to talk about dates and times for humans, and then dates and times for computers. And we'll talk about using functions to convert from human to computer dates and using formats to convert from computer to human. And we'll also talk about clock and date math. Now, a lot of the material I'm going to show you is just essentially clipped out of the Stata online help. So I recommend that you use that as a resource. It's very helpful. Well, how do people handle date and time? It's remarkably complex. For instance, right now it is Monday, June the 3rd, 2019 at 5:22 and 31.265 seconds afternoon. It's also the first half, the second quarter, and the 22nd week of the year. Now we've got months this year with 28, 30, or 31 days, and they're not in an easy sequence either. There's also leap years and even leap seconds. So it's just complicated. There are many purposes that we're going to use for dates and times, and therefore there's many representations, and we'll call these representations human readable formats. They're usually words and numbers, such as June 3rd, 2019, or maybe just numbers, 6/3/19, but not usually a single number to represent the date. Date and clock math are famously difficult. For instance, what is the average of Valentine's Day, Halloween, and Christmas? That is hard to do. Human readable formats are often ambiguous. For instance, 6/3/18 was during World War I. AM and PM is confusing. In fact, there's a famous photograph taken in Harlem of 50-something famous jazz musicians. Was done at 10 o'clock in the morning, and one of them famously reported, "I didn't know there were 2 10 o'clocks every day." So human readable forms are essentially strings. You like them, but your computer is baffled. Here are some types of dates and some human readable forms. For date times, which are, as it sounds like, dates with times, it might look like this to a human. 20 January 2010, 9/15/22, etc. Here's some dates, 20 January 2010 or 20/01 2010. That's a different form of the same date. If it was a weekly date, you might think, oh, this is year 2010 and it's the 3rd week. So the unit of analysis now over here was in fractions of a second. Down here it's days. Now it's just weeks. So anything that happened on inside this week, Sunday, Monday, Tuesday, etc., is all dated as 2010 W3. Monthly dates look like 2010 M1 or maybe January 2010. But business and accountancy often use quarters like 2010 Q1 or first Q of 2010. You can have half-yearly dates and then, of course, just the year. What year was he born? 2010. Computer representation of dates is quite different. Stata stores times of all sorts as numbers before or after midnight of January 1st, 1960. Its after are stored with a positive number. Times before negative, before this 0 time, are given a negative number. So dates are stored as the number of days since January 1st, 1960. Someone who was born on New Year's Day, 1960, has a birth date of 0. Someone who was born on the first day of the century has a birth date of 14,610 according to Stata, and I was born on -671. You can choose other base units, maybe weeks, months, quarters, half years, or years, so that someone who was born on this day, January 1st, 1960, has a birth week of 0. If they were born, say, on the first week of February that year, then they're going to have a birth week of 5. How does Stata store these numbers? Well, if it's a date that looks, for instance, like this, June 3rd, or this June 3rd, that'll be at 21,703, which is how many days since the beginning of the epoch, or since January 1, 1960. Again, this 22nd week is stored internally as a 3089. This 6th month of the year is stored as a 713, and that's the number of months since the beginning of the epoch. 237 quarters, 118 half years, and years it's the only one that it doesn't use the 1960 epoch. In that case, years are stored since the year 0. So the Stata internal representation of the year 2019 is 2019. Time is handled similarly. Stata calls time date time, and it's handled just like dates, excepting the unit is milliseconds, thousandths of a second. And there's actually 2 flavors. Clock time or date time with a little c assumes that every day is exactly the same length of 86,400 seconds, which of course is 60 seconds times 60 minutes times 24 hours a day. However, the big C adjusts for leap seconds and therefore matches universal coordinated time. And so that's important if you're comparing times over years or and need great precision. Since time is in milliseconds, the numbers tend to be really big, and so you need a double word storage. So if you're creating a variable that's going to hold time, generate a double with whatever the variable name is, equal whatever. So here's some examples. Date time little c. Here is a particular time. Maybe it looks like this, June 3rd, 1:39 in the afternoon and 30 seconds and 436 milliseconds. And that's going to be is that a billion? 875 million? No, that's a trillion. 875,188,370,436 milliseconds. And that's how many milliseconds have elapsed since the beginning of the epoch, assuming the same number every day. Here's the exact same time, represented a little differently though, because this has got the 24-hour clock. So it says 1339 instead of 139, and it doesn't have a PM. But it's the same exact time, excepting this time it's 1875188,397 436. So there's 27,000 extra milliseconds, or 27 seconds have been added for leap seconds since 1960. And those are to adjust minor changes in the period of the Earth around the sun. Okay, so if you have data coming in a human readable format, how do you get it into a Stata readable format? Well, there is a function for each unit. So there's one for dates, there's one for times, there's one for years, etc. They take 2 strings or string variables as input and output a single number in Stata internal format. The first string is a human readable format representation of the date, and the second is the mask that tells Stata the format that the HRF uses. So for instance, the format to get a date in will have a human readable formatted string and a particular kind of mask. And if you wanted to get a monthly, you can give it a string and a mask. And the masks show the components of the human readable format in order. So if your human readable format is June 3rd, 2019, then the mask should be the string, and therefore in quotes, that is month, date, year, capital M, capital D, capital Y. Caps matter. If HRF is, say, 03 June 2019, now that's the same date but a different format, now the mask should be, again, it's a string, so you use quotes. D comes first, then month, then year. Getting the mask right often takes trial and error. Let's do some practice with the date function. Well, what happens if we display the date function of this string with this mask? So this string is in the format month, day, year, so we gave it the right mask, and therefore it's going to spit out the Stata internal format number associated with this date, and that happens to be 21703. Here is the same string, the same mask, the same function, which says, give me the date associated with this string based on this format, excepting now we've said formatted as a date. And therefore, instead of 21703, we get a much easier to read date. By the way, we could have gotten exactly the same thing by saying display this as the same exact command with a different string. Again, though, this one is month, day, year, so that one works. We could even have thrown in some spaces in the string. It doesn't seem to bother that. What if we had said, oh, Stata, we've got month, day, year, hours, and minutes, but we don't have hours and minutes. Uh-oh, Stata comes back with a missing value. It didn't like that. But if we do have hours and minutes, it'll give us the right date. Notice it didn't give us the hours and minutes. It just stripped out the date and converted it to Stata. And that's because we ask for a date function, not a date time or clock function. To confirm that, we do this exact same command, excepting we don't do the format, which basically says, Stata, give it to me as a raw number, and sure enough, it's the raw number of days with no information about time. Here's some other human to Stata conversion functions. If you want to go from a date time with standard seconds, you can get a time variable and you use the clock command with a string and a mask. Again, it's a time, so it best be double. So TC just means it's a time variable in seconds. It's not so that could be any variable name you like, as long as it's a double. If you want it to be adjusted for leap seconds, you better give it the capital C over here on the clock command. Here's the date one that we just did, and it can be float or long. Either one will work. Weekly dates, you can use the weekly command. Again, any string that you can mask, if you ask it for a weekly, you're going to get the number of weeks since 1960. There's one for monthly. This one pulls out the number of quarters. This one, how many half years, and this one, how many years. And masks can use MD and Y as we saw. If you want to remind Stata that, well, I don't have all 4 year digits, so force it to be from the century 2000 or the century 19, the 1900s, you could use these. You could also use hours, minutes, and seconds, or even a hash mark, meaning skip this part of the string. And as we talked about, you can put a blank in and it will be ignored. Here's some more practice. If we ask it for the clock function of this string, we get back, well, 1.875 times 10 to the 12th milliseconds, which is, 2 billion milliseconds almost. Well, that's kind of, maybe you don't like that format. Let's ask it to give us a fixed column with commas, and sure enough, 8.75 and change billion seconds. What if we oh, what if we gave it the PM? Well, here it assumed it was AM because we didn't tell it otherwise. But here, since we're explicitly telling them it's PM, it gives you a number that's somewhat later in the day, about 43 million seconds later, which is about what 12 hours gets you. This one is the same string, but we're actually saying don't print it out as a raw number, print it out as a time stamp. And so you get this right out to the nearest second. And since we gave this 1 hour and 23, there's no seconds. It's very precise. What if we said monthly? Well, it would be 713. If we said monthly and format it, it would say, oh, 2019, the 6th month, in other words, June. And here is the same command run backwards. Give it 713. If we ask for it to display it as a formatted month, we get this. My advice is to try all sorts of combinations. Play around with this until you have some facility with it. It's can be tricky, but if you practice, you'll get a hand of it. I skipped over something, so I want to go back and point out that the masks up here are just month year because we didn't give it a date. This one and this one. If we had done MDY or MDY here, it would have failed and we would have gotten a missing value. Here's another function that's very useful. It's the quick convert function, where you give it a string in human readable format, and it has to be Stata's default format, which for dates is this thing of number, 3-letter month, and 4-number year. And if the TD function converts that into a date. So if we were to generate a new variable called sample date and set it equal to the Stata internal date that is represented by 03 June 2019, Stata would do that. And then if we said Stata display sample date, it would have given us 21,703. And then if we had said Stata display it again, but this time format it nice, we would have gotten this out. So in fact, this is the backwards of that, and you can run it either way. This is pretty much the handiest way to quickly get 1 or 2 dates into a Stata internal format. It's especially useful if you're doing something quick from the command line, and there are several other matched functions for milliseconds and leap seconds and weeks, months, quarters, and halves. Okay. What if your input is, say, one variable has got the month and another's got the date and the other's got the year, and we have separate variables that contain each of the time components. This happens fairly often, and Stata's got these build them up functions. So if you have month, day, year, hours, minutes, and seconds, you use this function and you give it a variable or a number, if the variable has to contain an appropriate number, separated by commas, and some variable that contains the month, some variable that contains the day and the year, and so forth. If you have just the date, the hours, the minutes, and the seconds, you can use this one. And you can use this one for hours, minutes, and seconds. If you need it to be in leap year, leap second format, then you can have to throw a capital C in front. This is the most commonly used one, where you've got month, day, and year in separate variables, and you want to pump them in and to create a Stata date, remembering that these are numbers. If you've got the year and the week, you can create a week. If you've got the year and the month, you can create a month, a year and a quarter, year and a half. And if you've got a year, you can turn it into a year, but that seems kind of silly because there is no change in that one. So how would you use this? Your data set, let's imagine, has three variables called mo, da, and yr, with each variable containing a date component in numeric form. To convert to the CIF, use the MDY function. So let's say generate event date, which is the MDY of these three variables separated by commas. Format event date as a nice neat date and run it, and you'll see it works just fine. And here are these other cousins that you could use if you need to. Now, once we get a date into Stata, the other problem is how do we now make it pleasant to look at for people in outputs? Well, dates are stored as unitless numbers, right? There's just, Stata just knows that it's 21,703, but it doesn't know if that's days, months, pickles, or ice cream cones. So you could display it just as a number, but maybe you want to tell Stata the units and the format you prefer. So the units show up in the format code, and it's either milliseconds or leap milliseconds or days, weeks, months, quarters, H and Y, and they all start off with a T because it's a time format. So earlier we saw the F format and the G format, and now we're seeing the T format. So we've got a number. Let's just display it. Well, Stata display 21703, and it gives you 21703. If we say Stata display 21703 but format it as a day, we get 03 June 2019. That's much more useful. Oh, I'm sorry, Stata, format it in milliseconds. Oh, well, that would be 21,000 milliseconds, or a little more than 21,000 and 21 seconds, and that's a pretty small number as milliseconds go, so it's really just a few seconds into the new year of 1960. If we said, oh no, format that as a week, well, then it's the 20th week of the year 2377, which is coming, it's just around the corner. So how do you take control of these date formats? Well, if we want to display this number, we use TD and get this night's date. If we use this format string, capital DD, MON, capital CC, capital YY, you get the same thing. So this is a quick shortcut for this. And this basically means 2 digits of the date, a 3-letter abbreviation for the month in lowercase, the century for 2 digits, and the year for 2 digits. And you get that. If we said, oh no, format the same number as a date, but give me N/D lowercase / capital Y, we'd get a 1-digit month, a 1-digit date, and just the minimum number of digits to get the year and the century, so 19. This one gives us very similar, excepting when you put the C in front, it adds the century. Well, there's a lot of format codes, and they're listed in the help file and in the online help, and they're listed on these slides. So double C gives you the century, and it gives you forces it to be 2 digits. So if it's a low century, you get a leading 0. The lowercase double C might just get you, early years in the Common Era will get you single-digit centuries. The same logic applies to years. So we're currently in 2019, but 10 years ago, a double Y would have gotten us 09, but a double lowercase y would have gotten us just 9, and that can be pretty confusing. You probably don't want to do that. J's are the number of days within the year. MON, month, little mon, month, give you strings. NN, upper and lowercase, give you numeric versions of the month. DD gives you numbers. If you want the day of the week, there's a half a dozen ways to get that out. If you want halves, quarters, weeks, you can get that. Hours, minutes, seconds, tenths, hundredths, and thousandths of a second. And if you wanted to show AM and PM, you got 4 different choices for how that can look. And there's more. If you want to have a period in the middle of your format, you can use that. You can also insert a comma, a colon, a hyphen, a space, which comes, you have to use an underscore for that, a slash, a backsplash. And if you just want some arbitrary character, if for some reason you like to use an asterisk or a something, an X between your dates, you can just do exclamation and then whatever character you want, and that'll show up in the format. And the plus sign is doesn't do anything, but it sure makes it easier to read. It's never necessary. So this one and this one, they're similar. You might find it easier to have the plus AM when you're trying to read it. Okay, let's move on to if you want to move from Stata internal to another Stata internal, which basically means changing the units. And there's a whole bunch of functions that I think of as the this of that functions. So if you have a time variable and you want the date, in other words, you want to convert it from a gazillion milliseconds to some thousands of days, you could do, divide it by 60 by 60 by 24 and by 1,000, or you could just say generate a new date variable that is equal to the date of clock of whatever the variable is, or the date of big clock if you're using a big C function. And there are cousins for these, like you can get the date of a week, and that'll give you the first day of whatever week you have coded. If you ask for the week of a date, it'll run it backwards. You can get the date of a month and the month of a date, and there's a pile of those. What about clock and date math? Well, we've talked about times and dates are stored as numbers on a continuous scale, but I want to point out that it's not a ratio scale. So you can add and subtract them and do all sorts of transforms. So, for instance, how long has it been since humans landed on the moon? Well, as I'm doing this, it's June 3rd, 2019. So that's this date, and that's a Stata internal date now that we've run it through the function. And we subtract this date, which is the date that they first landed on the moon, and which in 20th of July 1969. You subtract them, and we learn that that's 18,215 days, which is a kind of valid answer to this question, but maybe we want to make it prettier. Let's put it into years. So here's the same function divided by 365 and a quarter, and there's a little extension, formatted as 4.1f, and then after that display the phrase space years dot, and you get this nice 49.9 years. It's looks pretty good. So it's a way to make your output a little fancier. More on clock math. Let's do one of those awful junior high school word problems. The train leaves at 8:30 p.m. and arrives at 11:06 p.m. the same day. How long does it take to go the 117 miles between the two stations? Well, we can do this very similarly to how we did the other one. We have a clock. We're going to extract the time value in Stata, that is 11:06 p.m., and we'll subtract, that's our finish time, we'll subtract our start time, which we have as a human readable, but we'll use this to convert it into time. And that's in seconds. We could have used a conversion, but here I just said, okay, that's milliseconds, divide by 1,000 to get seconds, divide by 60 to get minutes, and divide by 60 again to get hours, and then tack on this string, and this display command spits out 2.6 hours. What is its average speed? Well, we know it's 2.6 hours, and it's 117 miles. We know the 117 miles from here and the 2.6 from there. So if you display 117 divided by 216 string blank MPH period string, you discover that this train is going at 45 miles per hour. What time is it halfway there? Well, assuming it's a constant speed, we can say, here's the beginning time plus, we actually could have done 2.6 divided by 5, but I just typed in, divided by 2. I just typed in the same phrase here that we used earlier. This time I divided by 2. And so now I have a number that's in seconds. And I say, why don't you take that seconds and format it as hours, minutes, and label it as an AM or a PM. And I did all that, and it says the halfway time is 9:48 p.m. Notice I asked it for AM here, but that doesn't force it to AM. That's a way of telling the format, please put the AM PM code in there. So it's important to go back and remember that Stata internal formats, that's not a ratio scale. They have an arbitrary 0 point back in 1960. Therefore, multiplication and division are not defined. For instance, we can divide June 3rd, 2019 by October 22nd, 1979. And what we discover is you get an answer of about 3. But what does it mean that this date is 3 times more than that date? Now, it means that it's 3 times further from January 1960. And if that's what you're trying to answer, that is great, but it's almost never what you're trying to answer. Now, if you subtract a meaningful start date from each, then you're back to a ratio scale and you can do multiplication and division. So for instance, if the question is this person was born on one date and another person was born on this date, so let's subtract the current date, we'll subtract each of these and then take the ratio of that, we could discover that one of them lived 3 times longer than another. That is something we could do. Okay, here's your assignment for Module 6. Please write a script to answer these questions. What is my birthday? I mean Ben Littenberg's birthday. And how old was I on the first day of this century? Please calculate the difference in our ages. In other words, the difference between your age and my age. How many weeks have elapsed between our births? Go back now and actually calculate the average of Valentine's Day, Halloween, and Christmas this year. Do it again for next year. Open this file, please. It's in the form of a CSV, and graph the distribution of ages at the time of analysis. There's a date of analysis for each subject. On average, how much time elapsed between the 2 readings for the A1C tests that are in the data set? And what is the average change in the A1C value over time between those 2 readings? Please figure out when did the most A1C tests get done, at least of the first sample, and tell us what month it's in. And then find the 5 oldest subjects in the data set and print out their dates of analysis, censoring, birth, and the first test. Now they've had multiple tests, so whichever of their tests is first. And printed out such that each date is in a different pretty format. Please bring your finished script to class on Monday, all ready to run. Thanks.